We're going to be talking about summation notation. And the idea behind summation notation is you may have sets of numbers. They'll start at a certain value and end at a certain value. And the idea with a sum is you're going to be adding the answers for each of those. So you can kind of see this whole mess of mathematical language in the middle. And to kind of break this down, this sigma notation that they give us, it gives us a few things. First off, it may give us a rule, something that's gonna happen. So some mathematics. We're gonna be starting at whatever value the index starts with. So that's our index variable I, and we're gonna be ending at the number at the top, which represents n. So let me show you in a couple examples. So if you look at A, this one right here, it says 2i, and it says below that I is 3. So to get the first term, it would be 2 times 3. And I have to keep doing that for each number up until I get to the number at the top. So I do 2 times 3. I'm going up by 1 each time. Then I would have 2 times 4. And then I would have 2 times 5. So what this comes down to is I got 2 times 3, 6, 8, 10. If I add these three together, I end up getting the number 24. And that number is going to be my final answer. Now, if I take a look at B, there's going to be an index variable of k. K equals -1. So I have to go from -1 to 3. So I'm going to start with -1. And I'm squaring it. Then I would do 0 squared, 1 squared, 2 squared, and 3 squared. So for these I get 1, 0, 1, 4, and 9, which ends up being 15. Now for C, we got j equals -2. So they want us to go from -2, start at -2, and get all the way up to 2. So it looks like j is an exponent. So I'm going to do 2 to the -2nd power, plus 2 to the -1st power, plus 2 to the 0 power, plus 2 to the 1st, plus 2 to the 2nd. So I'd get 1/4, 1/2, 1, 2, and 4. So if I was to input these all in, it ends up being 7.75, which I could write it as that, or you might see it as 27/4. Either one of those could work as an answer because both of them are the same value. Now, kind of moving on from those, you can kind of see exercise 2. Exercise 2, they give you 4 fractions. And it says they want us to do from 1 to 4, and it's 1 over I. So we have to do 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 4. So for each of these, you could go ahead and take the calculator. We know the first one is 1. I'm going to kind of try to reduce some of these. So we got 1 plus 1/2 plus 1/3 plus 1/4. So we get 2.08, and I could change that back to a fraction using the math option. So we end up getting 25/12, which would end up being choice 3. But again, you want to show that substitution and making sure you're getting each part as you work through this. So I'm going to go ahead and erase this. So we're going to look at exercise 4. And exercise 4 wants us to express each using sigma notation. So if you look at the first one, 9, 16, 25, up to 100, well, these are all examples of squares. So if I say I is going to equal 3, and I go up to the number 10, this would just be I squared. And I'd be adding those values together. Now, if we do B, in this case, I see each of the values increasing as I go to the right by 3. So we're adding 3 each time. So I'm going to call this 3n. And to get negative 6 as the first one, I'm going to need n to be negative 2. And I have to get to 15. And I know 15 is 3 times 5. So 5 is going to be the highest value I would use for this one. Now for C, C is showing multiplication by 5 each time. So for this one, kind of similar to what we were talking about earlier, well, this one I can do, I know it's a 5, and it's going to be 5 raised to a power. I'll use n again. And the first one is going to be when n equals negative 2, and then to get 625, that would be, actually, sorry, not 5, 4. So again, you want to make sure that each of these does make sense and that the starting value and then the ending value you can kind of figure out from the patterns you see. So I can use multiplication for this one because I'm seeing that change by 3. And this one is exponential because I'm seeing some repeated multiplication going on. So the last one we're going to look at, exercise 5. Well, they want us to figure out what gives us this sequence. Now, it looks like, and you really want to just kind of try some of these out. If I look at 1, I got 3 to the I power. Now, if I put in 3 to the first, that's going to give me 3, which is fine. But if I do 3 to the second, that's going to give me 9, which that one doesn't work. And if I go to 2, if I do 3 times 2 to the 0 power, this gives me 3. And if I do the next one, 3 times 2 to the first power, that's going to give me 6. And I'm going to do one more, 3 times 2 to the second power, that gives me 12. So those 3 match. And this one goes up to 4. And you could check the fourth one, that'd be 3 times 2 to the fourth power, which would be 16 times 3, which is 48. So this one does work, choice 2 in that case. And it's good to use the starting and the ending point when you're doing the checks. So, as you work through the summation notation, make sure that you are including every number from the starting value, like I'm circling, to that ending value. And you're writing each one out. It may be a little tedious, but you need each of those values, especially on short answer questions for work.